Hey everybody, this is Larry. This is me doing an extra bonus question on October 8th, 2022. Haven't done as many bonus questions as whatever. I've been just not sleeping well, to be honest. I have some, I don't know. I'm working on it. We'll see what happens. But yeah, that's the short story. So yeah, let's kind of do one problem that I haven't done before. I have about 800 of them that I haven't done before, so it should be easy. But there is a lot of premium ones like this one, so I have to keep on clicking. Let's try again. Okay, so let's go. Print foobar alternately. Suppose you're given a code. This is what you might call it. This is a multi-thread problem, which in Python is. I don't know how they do it in Python actually. Yeah, I have no idea how to do this in Python, so I'm gonna just do another one. Not gonna lie. Maybe I have to read up how they set it up, but yeah. And of course, I've done. There are a lot of premium problems. I have to subscribe. Maybe one day I'll subscribe just to do it. But as you can see, there's a lot, except for apparently transparency or concurrency problems. Okay, there we go. 719. Find kth smallest pair distance. Okay, so you have A and B. The distance is A minus B absolute. Nums and K. Find the kth smallest distance between all pairs. Huh. And N is going to be 10 to the 4th. So that means that if we try to do the naive N to the 4th and then sort it, that's definitely going to be a little bit too slow. The question is, can we do better, right? So it's going to be pretty tricky either way. So I have to think about this. This is not a easy problem for sure. The only wait, is it distance? Okay. So I mean, so the other thing that I was going to say is that because of this K constraint, meaning that there's no essential constraint on K being that it's just a routed entry, you can't do anything based on K. Like if you try to do a heap based on K or something like this, at least not directly, that doesn't matter because K is going to be O of N squared, right? So if you have K times even O of 1, that's going to be N squared, and N squared is too slow. So the thing that I would try to exploit is this thing, 10 to the 6. What does that mean, right? That means that, for me, it means that I can do a binary search. But let's see if it's going to be fast enough, right? So let's say we have 10 to the 6. What does that mean, right? So let's say N is 10 to the 4th. If we do a binary, I mean, in this case, there'll be 2 binary search, just to be clear. We'll do 1 binary search, so 10 is 10,000. So we do the first binary search, it's going to be what, like 15 something? 16? I don't even know anymore. 2 to the 10 times 4, so like 15, right? So, yeah, oops. Oh, oops, what did I click on? So yeah, so times 15 is going to be log n, because then now what my idea is that for every number we search for a given answer, right? And then now we do another log of 10 to the 6 this time, and 10 to the 6 is maybe like what, less than 20, right? Say, so that means that that's going to be our complexity, roughly speaking. And 20 times 15 times 10,000 is 3 million, which should be fast enough. But this being Leetcode and this being this being Leetcode and Python, who knows is the answer. So I'm getting like messages from a buddy. I should say hi, because I keep on missing her messages. But yeah. Whatever, I'll actually message her later. Okay, sorry friends, this is live, so you can kind of see my thought process, and my thought process apparently is that I'm very distracted. So let's give it a spin. I know that I skipped a little bit on the details, but the idea now is to binary search on the answer. And just to be clear, the answer, I didn't make this clear, so I'm saying it for the first time, and I'm going to try to say it clearly for the first time. And what I was going to say is that the answer has to be between 0 to 10 to the 6, right? Yeah, because um, because the biggest difference between two numbers is at most 10 to the 6. So the answer has to be 10 to the 6. So then now we can do something like left is equal to 0, right is equal to 10 to the 6. And of course, this is why I said the 20 thing. 20 is actually 10 to the 7, but you know, this is just a rough estimate, right? So this is actually even better for us. Yeah, and then this is regular binary search on the answer. Yeah, something like this, right? Oops. And then, of course, in the usual fashion, I do if good of mid. So I haven't done a full binary search video lately, so hopefully maybe this is one. I need to set that video out, but because I recorded it like 4 months ago. This is actually kind of lazy on my part. But yeah, so the idea here is that, okay, if this number is good, what does even good mean, right? So let's actually define that a little bit. So good of target, right? What's the target? Target is such that number of pairs that are, we might have to change that. I'm not clear on this one because these things I always get off by one. So even, yeah, we might have to think about this. But the smallest number, the number of pairs. So what does finding the k pair mean, right? K pair means that there are k minus one smaller, k minus one or more smaller targets, or given a certain answer, there is less than k things to it. I think there are fewer than k pairs that are smaller. Something like this. This one is for me like very hard. These kind of things, the k smallest because of the distinct value. If it's distinct, it's easy, but if it's not, then I sometimes get it wrong. So that's something that I'm only saying it because I'm just going with my thought process, obviously. But my idea is that like this is something that I keep in mind of, so that when something or if something does go wrong later, I'll be like, okay, I know that I was uncertain about this part, and this is about knowing myself. So let me revisit that part and make sure I understand it. But for now, let's get to it. Right? If there are k-field pairs, then that means that this is then we have to go bigger, right? Mid can be the answer, so but we have to go bigger because it may be too small. So okay, so left is equal to mid, and then else mid right is equal to mid minus 1, and of course then we have to add plus 1 here, and then we just return left in theory. I have to think about this one a little bit. This, I mean, like thinking about like this case, but we can finish writing it and then we'll see. The idea here, of course, is and we forgot to do this, and by we is because you know I don't know. Okay, sorting, right? Wait, what am I doing? Yeah. What am I doing? Okay, I think I have an idea, but I forgot. Right? Not gonna lie. Yeah. So basically, wow, there's two binary search, right? Because basically for a target that is a solution, wait, the distance, right? So this is the target's distance, and that means that we're trying to find for I, find minus I and plus I, right? So basically we have something like this. So index is equal to well, wait, we have to do it for x in nums, right? So this is x minus target, and of course I have to actually, this isn't a thing, this is the thing. Index left, I might have to fix some stuff, but this is the idea, right? Something like that. And hopefully this is going to be fast enough, to be honest. Okay, right? And then now, of course, we have to kind of do an index, right? So we want this -1, I think. Yeah. And then now, because we know that by definition, x is going to be inside this thing, we can just do total is count is equal to 0. And then we do count, we increase by index right minus index left. We want to +1 because we have inclusive bounds, and then we want -1 because we have x. So this should be maybe good. And then we want to count that count is so these are the numbers that are target or smaller, right? So this is the number of pairs that are target or smaller. So this means that, yeah, so we want this to be less than k, I want to say, but I am so not confident about this. This stuff is hard. So let's run it real quick, and we got it wrong in the first one. Oopsie daisy, but that's actually also wrong anyway. But that may just make it slower. Expected 0. Oh, maybe we have to do like a -1 thing, but that doesn't change the, or shouldn't change the answer that much anyway. But let's see. And here we can actually choose max of nums just to make it slightly easier. Did I get at least number 2 right? No, I get 10,000 as well. No, 1. Why do I get 1? Did I mess this up? So that means that they're, if good, maybe I'm inversed what I mean. So a good means that we have k or fewer. So we want a bigger number, right? Did I say that? Yeah. So we want a bigger number to hopefully get to the other side. But yeah, should be right. So maybe this part is wrong. All right, let's see. Oops. What did I click on? Did I submit? I hope I didn't submit. I guess I did submit. That should not be a shortcut key. I think I complained about this the first time I seen it, but maybe in the old one, I think they got rid of it. Or maybe in contest they got rid of it, but apparently it's still a shortcut and I made it by accident. Who needs, I mean, who is that, like, needs to save half a second to click on submit and get a 5-minute penalty instead? I don't know. But okay, let's take a look at this one. So the first target is 1, because it's going to be 0, 1. These should be inclusive. Okay, that's right. So then the first number to try is 1. Is 1 good? 6. 6 is definitely higher than, is 6 right? I think I did a mistake here because there's not 6 pairs, right? I think maybe that's why, because I'm double counting from the other side. And this is n log n times, yeah, okay, that part is fine. I mean, I could think of another way of with sorted list or something, but I'm trying to think without it first. Well, I'm also being silly. This is not that necessary. I think you can do sliding window, right? You could maybe you could binary search for the first time or whatever, but then you could do a sliding window from it, right? You have middle and then just keep on moving the left and the right. So there's one place where we can make, we can speed this up, but the pair backwards thing is a little bit awkward. Okay, I get it. I think I was trying to be too clever with this sliding window thing on left and right, but actually we only have to look at the numbers to the right of it, meaning the numbers that are bigger, because if the numbers that are smaller that on the left of it, then you can assume that the left pair already took care of it, right? Because of this symmetry. We can also maybe just divide it by 2, to be honest, but okay, let's divide it by 2 real quickly, just to kind of see. But I think there are a lot of places for optimization that we just talked about, even though I accidentally clicked on submit, but we can kind of start with this. Yeah. Okay, this is not great still, because 3 is clearly cannot be the answer. What do I have here? This is just me putting out 1 again. Okay. What if I do k minus 0, 1? I mean, it's still going to be wrong because it shouldn't be 3. Why is it 3? Let me print it again. Target count k. I don't know what shortcut is for submit, but that's a very sad shortcut. Okay, so distance of 2, we have 3 pairs. Is that true? So we have 1, 1, 3. Let me try to work it out manually, right? Just to kind of trace the code a little bit. So we have 1, 1, 3. So this one we found 2 numbers. This one we found 2 numbers. And then this one we found 2 numbers. So that's 6 divided by 3 is 2. Divided by 2 is 3. But that's also true. Did I misunderstood something? 1, 3. Does the order matter? Order doesn't matter. Right? Yeah, no. 1, 3, 3, 1. Yeah, I guess so. There are only 3 pairs, right? So, and all 3 is good. So okay, so then the 2 it goes. Okay, the 3 numbers bigger, smaller. So count is greater than 1. So that means that we want a bigger number. That doesn't make sense, right? I think I messed up the sign again. I guess that's it. Because if there are more pairs, then we have. Yeah, okay, Larry, you silly goose. Okay, fine. I don't know why I said it that way though. Okay, let's see again. Okay, so at least now we're making progress. We got the first 2 correctly, even though who knows if it's like from silliness or not. All right, 161. The answer is. So I think this is the part where I was worrying about, because 4 is not a possible thing in here. But we're returning the first case in which the k minus 1 number is smaller. I think that's the problem. So what we want is actually the first case where this is true. And maybe that should be good. But now maybe we don't need to do k minus 1. Let's see. Because we want to find the first case where this is true. And we have to subscribe to reduce waiting time and also turn off autocomplete apparently. Okay, so now this is very well. We want the this is always troubling for me. We want the first number. This is the part that I said I was going to struggle with, and I proved myself wrong. Proved myself correct, because this is the first number in which this is the first number in which there are to bring this back. No, that's actually a little awkward. The reason why this is 4 is because this is the first. Wait, is it? No, because the pairs should be 5, 5. Oh, so this is the biggest number where there's 2k smaller. Okay. So how do I fix it? We want to. So this is the. Okay. So that means that if this is good, actually, we want this to be +1, and then this. Maybe this is good. I think, because we want. No, is it? So this is good. Yeah, we want the first case where this is true. Okay. Let's give it a quick submit. This may time out, but we talked about some stuff to optimize. Okay. Well, that is just sad. It also is the same kind of issue. So let's see. What am I doing here? Well, 38 is not even. Oh, actually, it is a possible answer, but maybe I got a number wrong, right? Because 38 is the first one. That's true. Why is that giving me wrong? All right, let's see. Okay, well, because 38 should be when 38 count is equal to 1 and k is equal to 1. Oh, well, k doesn't change. So we want the second number. 38 should not, I mean, the first number is 38, right? So then it went smaller after that? That doesn't make sense, right? I think maybe I just have to do this. Okay. Yeah, I think when I changed the signs, I should have thought, I mean, not that I should have thought about it, but what I should have done is just tested it, to be honest, because this is very testable, right? Like, this is literally a vanilla 3-number answer, but I'm just lazy, and I'll do this one, and yes! That one was harder than expect. Well, I mean, terrible time because, like I said, there are a couple of optimizations that we can do. For example, this is log n or n log n. Let's go with the complexity, right? So this is let's say r is equal to range, meaning 0 to max nums, right? And then you have log r is this, obviously is the number of iterations. Here, good, it's going to be n log n the way that we did it, right? So this is n log n. So then in total, so in total, the time complexity is going to be O of n log n times log r, and oops, I didn't submit again. I don't know. And then space complexity, of course, is just O of n because of this sorting. Again, I mean, that's how I always say, when we sort, then we do it. But of course, we can actually reduce this log n factor by using a sliding window, right? And also just not double counting, I think. So we can, let's do it. Today I'm feeling optimization-y, so let's do it. Of course, you still have to do the sorting, so this is going to be plus n log n anyway, but at least you don't multiply them, which is kind of ridiculous. But yeah, first of all, we can do index right to kind of look only to the right. And then this is just, of course, enumerate. Oops. Yeah. And then this is, of course, just like I plus 1, but inclusive. Right? So then you plus 1 again to include the bound. And then, of course, these cancels out. So you have something like this. And then now we don't need this. And it should be slightly faster. Hopefully correct first, and then we'll, yeah. Let's submit again. Okay. Yay, we moved from 5% to 12%. Okay, but like we said, we can still do this with sliding window, right? Yeah, right? Because basically, you want to, let's say, yeah, let's see. Let's say we just do it on the first one because I'm too lazy to do it. And then you have nums sub 0 plus target, right? So you have index right. And then here, for every new I, what are we doing, right? So while index right plus 1 is less than n, and num sub index right minus x is less or greater than or less than or equal to target, then we index right increment by 1, right? This is actually plus 1 because we assume that the current index right is good, right? And then that's pretty much it, I think. Let's run it again, make sure it's right. Maybe I've off by 1. It's very easy to off by 1, and I forgot to do it. Oh, I guess I just didn't. I usually have it write it very quickly, but I guess this time I didn't really need it until just now. Okay, so that looks good again. So let's give it a submit. Cool. Now with in average 56% category, I feel a lot better. And of course now you can see that this is, I mean, there's a log n here, but that's only one log n. It's going to be dominated by this O of n. So this is just going to be O of log r. I mean, O of n log r times plus n log n. So that's much faster and much happier for me. You may also wonder why this is log n, this is O of n, even though there are 2 for loops essentially. But you can think about index right can only go up to the right, like it can only this particular statement can only increment O of n times, so it gets amortized out, right? So in aggregate, this is going to be O of n. Yeah, that's pretty much all I have for this one. So let me know what you think. yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.